Hello everyone, Sam Butchart here with the first of two short videos reviewing the basic ideas of deductive validity and valid and invalid forms of argument. So just to remind you of the definition of deductively valid, or just valid for short, an argument's valid if it's impossible for the premises to all be true and the conclusion false. And by impossible here we mean something like there'd be a logical contradiction in thinking that the premises were all true and the conclusion was false. So in a deductively valid argument, if the premises are all true, the conclusion must also be true. But it only says if. It doesn't mean that the premises are actually true. Deductive validity is a type of support. It's the strongest possible kind of support that premises can give to a conclusion. But it's important to remember that support is not the only criteria for a good argument, for a successful or cogent argument. The other criterion is that the premises have to actually all be true. And calling an argument deductively valid doesn't mean the premises are all true. It just means if they were all true, the conclusion would also have to be true. So the next idea to get clear on is the idea of a pattern or form of argument. If you look at the four arguments here, you will see that although they're all quite different in terms of their content, they're also very similar to each other in a certain way. They all have two premises and a conclusion, and the first premise states a conditional claim. For example, if Joe lives in Melbourne, then he lives in Victoria. If Mr. Green is the murderer, then he would have blood all over his clothes. If the patient has a pulse, then the red light will be off. So the first premise is a conditional claim like this. If something is true, then something else is true. If A, then B. And then the second premise says that B is not true. Joe does not live in Victoria here. Green does not have blood all over his clothes. And in each case, the conclusion is then that the first thing, A, is not true. Joe does not live in Melbourne. Green cannot be the murderer. The patient does not have a pulse. So all four of these deductively valid arguments fit this pattern. And they all look like this. If A, then B. B is not true. Therefore, A is not true. Just to illustrate that for each of the arguments, here's the first one again. And here I've just coloured in the component statements in the argument to show how they fit the pattern. The first premise of the first argument is if Joe lives in Melbourne, then Joe lives in Victoria. If A, then B. If red, then blue. Second premise says it's not true that Joe lives in Victoria. B, the blue part, is not true. Conclusion, A, the red part, is not true. Here's the second argument. If Mr. Green is the murderer, then he has blood all over his clothes. If A, then B. And the second premise tells us that B, the part in blue, is not true. B is not true. Green does not have blood all over his clothes. Conclusion, A is not true. Not true that Green is the murderer. I'll leave you to look at the next two slides for yourself to see how the other two arguments also fit this pattern. Here's that pattern of argument again. If A, then B. B is not true, therefore A is not true. This pattern of argument is called modus tollens, and you can see, I hope, that any argument that fits this pattern will be deductively valid. You can perhaps see this quite clearly from this diagram which represents the first premise, if A then B. So you have a small circle representing A, completely inside a bigger circle representing B. So obviously, if a point is inside the A circle, then it's automatically inside the B circle. If A then B, which is what the diagram is supposed to represent. But notice we can also see from the same diagram that if a point like this one is not in B, then it can't be in A either. And that's why modus tollens is valid. If A then B is in fact equivalent to saying if B is not true, then A is not true. Compare that to this form of argument, which is not valid, denying the antecedent. It looks similar. The first premise is the same. If A is true, then B is true. But then instead of B is not true in the second premise, we have A is not true. And we try to conclude that B is not true. But you can see, perhaps from the diagram, why that's not necessarily valid. Again, the two circles represent the first premise, if A then B. If a point's in A, then it's automatically in B. But that doesn't mean that if a point is not in A, it's therefore not in B, because a point could be here. That point's not in A, but it is in B. You can also see why this form of argument is not valid by considering examples like this. If Joe lives in Melbourne, then he lives in Victoria. If A, then B. Joe does not live in Melbourne. A is not true. Therefore, Joe does not live in Victoria. Therefore, B is not true. Well, that conclusion doesn't follow because, of course, Joe might live in one of the other cities in Victoria. So, to check your understanding, here's a quiz question. Here we have an argument. If global temperatures are increasing, sea levels would be rising. But sea levels are not rising, therefore global temperatures are not increasing. Is that the valid pattern, modus tollens, or the invalid pattern, denying the antecedent? You should just pause the video here, think about your answer to this question, and then go on. Did you get it right? This is valid, modus tollens. It has the form if A then B. If global temperatures are increasing, sea levels would be rising, but sea levels are not rising. B is not true. Conclusion, global temperatures are not increasing. That's saying A is not true. That's the modus tollens pattern, which is a valid pattern of argument. But wait, you might say, don't we all know global temperatures are increasing? The conclusion here is false, isn't it? Yes, it almost certainly is. But remember, deductive validity support is just one criterion for a good argument. The other question is whether the premises are actually true. And that would be where this argument fails. Not all the premises are true. One, or perhaps both of them, would be false. But there's no problem with the reasoning here. If the two premises were true, the conclusion would have to be true. Let's look at one more valid pattern of argument and one more invalid pattern of argument. Here is the valid pattern of argument, modus ponens, probably the most obviously valid kind of argument you can have. If A then B is the first premise, and now the second premise says simply that A is true, and we can conclude that B is true. Well, that's obviously right. If A is true, then B is true. If a point is in A, then it's in B. Have a look at these examples. If it's raining, then the party will be cancelled. And it is raining, therefore the party will be cancelled. Valid. If Miss Brown's DNA does not match that found at the crime scene, then she's innocent. And her DNA does not match. A is true, therefore B is true. She is innocent. Again, any argument fitting this pattern will be a valid argument. You couldn't have an argument fitting this pattern with true premises and a false conclusion. However, you can have an argument fitting this pattern which has true premises and a false conclusion. So this is not a valid pattern of argument. If A then B, B is true, therefore A is true. Well, here's the diagram again, representing if A then B. If a point's in A, then it's in B. But that obviously doesn't mean that if a point's in B, then it's in A. So this form of argument is invalid. Consider these two examples. If it's raining, then the party will be cancelled. If A then B. And the party has been cancelled, that's B. Therefore it is raining. Therefore A. Well, this doesn't follow because, of course, the party might have been cancelled for some other reason. This premise just says that rain is one reason why the party might be cancelled. It doesn't say it's the only reason why the party might be cancelled. It doesn't mean the same thing as if the party is cancelled, then it's raining. If A then B doesn't mean the same thing as if B then A. Look at this example. If Rover is a poodle, then Rover is a dog. That doesn't mean the same thing as if Rover is a dog, then Rover is a poodle, because that's not necessarily true, although the first thing is true. So this is not a valid form of argument. There are examples where the premises are true, but the conclusion isn't true. Second quiz question. Here's another argument. Is it modus ponens, the valid form, or affirming the consequent, the invalid form? If there's no problem with the engine, none of the warning lights will be flashing. None of the warning lights are flashing, therefore there's no problem with the engine. Valid or invalid? Again, pause the video for a moment and think about your answer before continuing. Hope you got this one right. This is the invalid form, affirming the consequent that we were just looking at. If there's no problem with the engine, none of the warning lights will be flashing. If A, then B. And then we're told that B is true. None of the warning lights are flashing. Conclusion, there's no problem with the engine. That's saying that A is true. Therefore, A. Well, this is the invalid pattern, affirming the consequent. If A, then B doesn't entail that if B, then A. So there's a practice quiz on Moodle that goes with this video. I suggest you have a go at that now. It asks you to analyse the form of various arguments and to say whether they're valid or invalid. All of them are either the valid patterns, modus ponens or modus tollens, or the invalid patterns, affirming the consequent or denying the antecedent. When you've had a go at that first practice exercise, have a look at the next tutorial video.